Hello, everybody. So in this video, I'm going to be discussing two-mean hypothesis testing for paired data. So let me go ahead and share my screen and we'll get started here. All right, so here's our first example. So researchers want to know if a new diet pill causes people's weight to decrease. And so we have the weights after the diet pill and before the diet pill. So notice here we have pairs of connected data points here. So instead of having two independent samples, the two test samples are connected. So, because each person has a before and an after weight. So this is going to be paired data. And what we're testing here is we're testing the mean difference between first column minus second column. That's basically what we're testing. So my null and my always for these problems, the null is that the mean difference equals 0. The alternative, so since I want to know if the diapel causes people's weight to decrease, that means that the after minus before, the mean difference, I'm expecting it to be less than 0 because I'm expecting the after weights to be below the before weights. So that's the non-alternative. So let me show you how to put it into our Rguroo now. So let's download the 10.3.9 weights dataset. Go ahead and import it into our Rguroo. So data import dataset. Choose the file from the downloads folder. And then remember, if you have a header in the first line, you select first line, or if you have a title in the first line. If you don't have a title in the first line, you would select no header. Just double check the Newton datasets to make sure there is a title in the first line. Mine always have a title in the first line. Hit upload. And then we're going to go to analytics, analysis, mean inference, 1 and 2 population. I'm going to select my data set and my two variables, which are after weight and before weight. Just ignore the person variable. That was just a label. Then you're going to check paired data, and notice how it brings it into one data set with the two columns subtracted. So it's testing the mean differences now, the after minus before. And then go to population 1 minus 2, test the hypothesis. My significance level here is 0.1. And then my alternative was less than 0. And then check T statistic. It's always T statistic on these because we never know the population standard deviation. Hit the eyeball. I get a p-value of 0.087, and then this is the test statistic if you're ever asked for that. So that p-value is less than my significance level of 0.1, so that means I'm going to be rejecting the null hypothesis. And if we reject, that means we have sufficient evidence that the HA is true. So we have sufficient evidence to conclude that the mean difference between the after and before weights is less than 0 pounds. So once again, I'm writing the alternative here in sentence form, which is saying the mean difference between after and before is less than 0. So we have sufficient evidence that HA is true, writing HA in the context of the problem. All right, let's do another one. So researchers want to know if there's a difference between the weights of a mother's second-born and first-born children. Assume the distributions are normally distributed or significance level is 0.01. So once again, this is paired data. You see we have pairs of connected data points by the mother. So my null for this is always that the mean difference equals 0. And then I just want to know if there's a difference here between the weights. So I'm doing second minus first here, the left column minus the right column. It's always left minus right. So I just want to know if there's a difference. So that's going to be not equal to 0 for the alternative. So the use of D, like I said, means mean difference. So this is just saying, is there any sort of difference other than 0 in the mean difference, either higher or lower? So the second board could be higher or lower. I just want to know, is there a difference from 0 when we do second minus first, basically? Okay, let's go to our Rguroo and put everything in. So let me click before I move on, remember if you want to save these, you can put a title here and then hit save as. So let me go ahead and close all this out here. Right click and delete. All right, so I'm going to go and download the child weights data set from Blackboard. And then data import, import data set. Choose the file from your downloads folder. Remember, the header on the first line is if you have a title on the first line, mine always do. Double check the ones on Newton. Hit upload. Okay. And then analysis, mean inference, 1 and 2 population. Select the data set. Select the two variables. Ignore the mother variable. Remember, that was just a label. Check paired data, so it does second minus first. And then population 1 minus 2, test of hypothesis. My significance level is 0.01. That is going to be not equal to 0, since I just want to know if there was a difference between the weights. So I just want to know, is the mean difference different than 0? And then t statistic, because I don't know the population standard deviation, and then hit the eyeball. You get a p-value of 0.6538, and then this is a test statistic if you're ever asked for that. So p-value is higher than my significance level of 0.01. So that means I'm going to be failing to reject the null. And if we fail to reject them, means we don't have sufficient evidence that HA is true. So we don't have sufficient evidence to include that the mean difference in weight between the second-born and first-born children is different than 0 pounds, which is what the HA is saying here. The mean difference between the second and first-born children's weights is different than 0 pounds. All right, let's do one more. So teacher wants to know if a new teaching approach is going to increase her students' test scores. Students will do that. The teacher will do this by comparing the test scores of her students on a previous test and the next test. And then we have our table here. So once again, pairs of connected data points by student. So my null here is going to be that the mean difference equals 0. And I want to know if the teaching approach is going to increase the student test score. So I want to know if my differences, test 2 minus test 1, are going to be greater than 0. So I'm expecting test 2 to be higher than test 1. All right, so let's go to our Rguroo and enter everything in here. Close all this out here. Right click and delete the data set here. All right, so let's download the test scores data set off Blackboard. And then data import, import data set. Choose the file from your downloads folder. And then header on the first line. If you have a title on the first line, my data sets always do. Just double check the ones on Newton. Hit upload. And then go to analysis, mean inference, 1 and 2 population. Select the data set and the variable. Check paired data so that it does the test 2 minus test 1. Population 1 minus 2, test of hypothesis. Significance I believe was 0.05. Yes, it was. And then my alternative was greater than 0. And then check T because we don't know the population standard deviation. Hit the eyeball. I get a p-value 0.0002. And then this is the test statistic if you were asked for that. So that p-value is less than my significance level of 0.05. So that means I'm going to be rejecting the null. And if we reject them, means we have sufficient evidence that the HA is true. So we have sufficient evidence to conclude that the mean difference between the test 2 and test 1 scores is greater than 0%. So once again, writing this HA here in sentence form, which is saying that the mean difference between the test 2 and test 1 scores is greater than 0%. And that is it. So that is two-mean hypothesis testing for paired data in our Rguroo. If you have any questions, please feel free to reach out.